Oh,
But it's not a ton of them, I guess.
I'm gonna cry.
It's like 4 problems, but in 2 they tried to make it look nice.
I think what Kayla is thinking right now is like, oh, can we not do this? It's like, it's super hard.
It looks super hard.
Yeah, it is.
Yeah. Okay. Well, yeah, it's no fun. I didn't love this the other day either.
I didn't like this one at all. This one's just like giving me headaches.
Okay, so 1A. We have sine x over 1 minus cosine x. I feel like this one's not too bad, though. If I'm thinking correctly.
If it equals to 1, I'll be very surprised.
Yeah, it will.
I was going to say, this one should just be 1.
Yeah, it should be 1.
They just cancel each other out.
Mm-hmm.
Wow, that was easy. I didn't have to do the work. Sweet.
But they're probably going to want us to write out our work, right? Where you actually add them together and
Yeah.
common denominator and all
Yeah,
that
that's.
jazz.
Yeah, they're probably gonna ask like how you got 1.
Yeah, they probably take a few points away if we didn't.
But we still got the
There's
correct
some way-
answer.
Is there some way we could just inverse one of them without affecting it?
I don't think, not
No.
that I recall. What we could do, we could put the 1 minus cosine x over sine. So that's going to be,
Okay.
the 1 minus cosine, what is that one? No, that's 1 over cosine.
Oh gosh, we sine x.
I don't remember what it is.
It should be. Well, it should be the greatest common denominator.
Well, it's pretty much, if we just get rid of the 1 minus, it's
Oh.
tangent inverse.
Okay, that makes
inverse
sense.
tangent. And then you put the 1 and I believe it becomes cotangent. But cotangent is more 1 over cosine.
It should be tangent. What do you think, Taylor?
Like she's saying, because it makes it tangent x over 2.
Okay.
We can just.
Yeah.
I'm wondering if we can write it as tangent x over 2 plus arcsine tangent.
Oh, yeah.
2 over x. And then it would just be x over 2 plus x over 2, or 2 over x, and then we'd just greatest common denominator on that, add it together, and then just write it tangent, whatever, or 1, if it comes out to 1. Because it might not, because it's plus.
Yeah.
I got to thinking, because if it was times, then it would definitely just be 1, but where it's plus, it might change that.
Yeah.
Yeah, if it was tangent, like what Taylor said, turning out to be like tangent x.
Yeah.
Yeah.
Hmm.
Oops.
Okay, I see what you're saying. Hmm. Book. Patch. Now,
Heck, I think it might equal 4.
wait, it really will?
Because you got to times 1 by x
Yeah.
to make it 2x on the bottom. And
I
you
was
got to
gonna
times the other one by 2.
Doesn't it technically become like 1/2 kind of? And if you, yeah. That's,
Well, the problem.
well,
well-
because if you have like the x over 2,
Yeah.
my mind went to 1/2. It's like, okay, from there,
Because I had x over 2 plus 2 over x. And then I times 1 by x and the other one by 2. So I got x squared over 2x plus 4 over 2x. And then when you add those together, it becomes 4x squared. Ooh, 4 plus
Wait.
X.
Okay.
Thing.
okay.
And then so you get 4 plus x squared over 2x. And then if you simplify that, you divide the 2 out.
Mm-hmm.
You get 2, and then x squared divided by x should be 2, right? So then that's just 2 plus 2. Equals 4, I think.
Close.
But I'm not even sure if I'm going the right way with this.
Mm,
Um.
that is a good question.
Let's see. Ooh,
Mm,
okay. One moment. Do you remember what section this was in the book?
I'm looking for it. I think it's 6.3.
Pretty sure.
Yeah, I'm pretty sure Taylor might be right.
Looks like they did this in the Google Hangouts thing, and it's got the answer.
Really?
What? Are you cheating? I was like, cheater.
Technically.
Where was it?
In the Hangout question.
Yeah.
One of them that they did is tangent x over 2,
Okay.
which is 1 minus cosine x
yeah,
over sine x.
yeah.
Hmm.
How to use that, aren't we?
Yep.
You may only use your textbook notes and calculator. Okay, so can't use that.
Can't use our assignments for our quiz, so.
So we'll go back to the book.
We can't use our assignments. Fetch!
Usually I'm pretty good about taking good notes while doing assignments.
Yeah, you're probably right.
I haven't been as much lately, which is a shame.
Reread. Trying to find it.
I know all I have is what we did in the beginning with all the pies and yada yada. Not the cosine and stuff yet. I guess we'll go into it, but
Because we ate pie yesterday.
I didn't.
What?
Didn't.
I want made chimichurri pie.
I was in class and then at work all day.
Aww.
I did not have pie at work.
I would have come over and given you pie. Wait. I'm not gonna cheat.
You're not gonna cheat.
No, I'm not gonna
It's in the
cheat.
book or somewhere.
It's in the book.
What page?
I don't know if I'm right.
I have stuff that has like the tangent.
I think it's on 6.4.
Oh, the half angles.
Yeah, I think it's in 6.4. I'm looking on page 455.
Oh, yeah. I didn't even think about that, but yeah. Yeah. It has something very similar.
I still wondered if it's to. This almost looks exactly like the similar one we just did.
Mm-hmm. Yeah, it's here. Here's the problem. It is very similar.
But it's backwards.
Yeah. It just breaks it down a little more.
Yeah, it did. Because if we just put 4, I don't think she's probably looking for that.
Well, but with how I did it instead, I would end up with 2 tangent squared of x. But I don't know if she wants the tangent squared.
Because I don't want to put 2 as my answer, and then I get it wrong about where's the tangent thing. So I'm taking a chance.
So I was looking at tangent, and I don't think we can use it because
It would be more cotangent, wouldn't it?
Right.
yeah. Tangent changes. Like if you put cosine on top, it becomes 1 plus rather than 1 minus.
Um,
So I don't think we could just put it directly in. You might have to use cotangent.
yeah,
So it would
Okay.
change how it reacts.
that's true.
But I'm thinking we can just times it by the inverse because it would be cotangent,
Oh,
just
yeah.
to get the 1 minus cosine x on the bottom. So we just make it tangent,
Okay.
and then it shouldn't change. It shouldn't change it at all, as like what it's equaling.
So to be fair, we should put 4 tangent squared.
So it should become sine squared, or sine squared x, I think. Sine plus sine becomes sine squared. Yeah, sine squared
Uh-huh.
x over 1 minus cosine x. And then I don't think we can reduce that anymore.
I don't think so either.
Oh.
So are you gonna go with sine squared x?
I think so.
Yeah. Yeah.
Okay.
Oh, I don't. Yeah, I think Taylor's right. Because of that 1, I don't think we can reduce that.
Mm,
Or we could do it the other way. We could flip the other one.
yeah.
It's like, get
And
rid of
then
that
we'd have-
throw it in the garbage.
Mm,
What would that be? 1
Minus.
minus cosine x plus 1 minus cosine x. Cosine is a negative. What does that do to that 1?
I always wonder if it wants us to almost do kind of like what they're doing here in the book.
Uh-huh.
I end up with a 1 over cosine or 1 over sine.
Uh-huh.
Yeah. I still wonder if we
It
should.
would end up being 1 minus cosine x squared. That would leave us with something like this right here. Oh no, that's a plus anyway.
Yeah, but that's kind of backwards.
Mm-hmm.
So if I wrote this out. Should be sine squared plus
That's weird.
x squared.
Because that would be like. It would be like 2 minus 2 cosine x all over sine x. Because the 1 plus 1, so we'd have 2 with that.
Yeah.
Then it's cosine plus, or negative cosine plus negative cosine, which should be negative 2 cosine, right?
Yeah.
Yeah, I think so.
So I'm thinking that's what it would look like. Yeah, because we have to get sine on the bottom for tangent. 1 minus. Because otherwise we'd be working with cotangent. I don't know if they want their answer in tangent or cotangent. Probably tangent.
Yeah.
I think tangent.
Cool. Tangent.
Let's go with tangent.
And so I think
Look how we switch it
simplified
in here.
version should just be 2 minus 2 cosine x over sine x.
I just feel bad for Galen because she's probably writing this whole thing out and she doesn't know what to write.
Yeah. I don't know
That's
what to
why I
tell her.
always do it. That's why I always do it in a notebook, and then I switch it over to the quiz page.
Oh.
Cheater.
How can
Your Mission Impossible, Caitlin. Holy crap. Okay.
Okay.
So, I think we're all right. We should leave that in tangent form
Mhm.
because I'm checking in page 453 for the half equal identities. Well,
Mhm.
I was thinking that it should be like in tangent form.
Yeah.
Because
In the book, they did an example kind of like this, and they didn't. I guess I did flip them. Looks like you can solve it by either flipping them or adding like values to each one.
Yeah.
Yeah.
I'm not sure if that will give us a different answer or not. I'm gonna try that one.
Tangent of x. Oh, wait. Maybe it's something, yeah, along those lines. So it should be like tangent x over 2. No, come back! Ah! 2 over x. Should be 4. X. What the? Give me like x squared plus 4.
Okay, so let's do this. So rather, So take sine of x over 1 minus cosine x and multiply that by sine over sine, or by sine, really. Multiply that to get that common denominator, and then take 1, or take plus 1 minus cosine x over sine x, multiply that by 1 minus cosine x. So we can get our common denominator. So in the end, we'd have sine squared x plus cosine squared x plus 1 minus 2 cosine of x, I believe, all over sine of x 1 minus cosine of x. And that's if I skip a few steps.
Nice.
Okay.
Um,
You skip a few steps? Oh, Caitlin, you're supposed to be the master. Huh?
and then we should be able to use the Pythagorean. I think we can use the Pythagorean identity.
Okay.
That's the case.
Oh.
1 plus parentheses 1 minus the 1 plus 1 2 cosine x all over sine of x 1 minus cosine of x.
Wait, doesn't it become positive? You can't use it. Because negative cosine times negative cosine becomes positive cosine.
That would be true.
That might be true.
The negative times a negative becomes a positive.
Positive.
Because it becomes cosine squared. Yeah. Do your
Oh yeah.
find that with the basis.
Because the positive.
Cosine becomes plus cosine squared.
Let me see.
Oh, wait a second. Wouldn't it be sine squared x minus cosine squared of x?
Sine squared of x.
Uh-huh.
Why would it be minus?
Let me see. Because if I just break it up, it's Because then it's 1 times negative cosine of x, so that's cosine x, and minus another cosine x, then plus, oh no, plus cosine squared, right? Just kidding.
That should be a positive.
Your ones will stay the same because 1 times 1 is just 1. And then your
And then with that
cosine-
negative.
Dang it. Freaking water bottle. Is there anything I can do to manipulate that?
Nothing we can do. I swear.
Yeah.
Because we can't flip the sign.
Mm-mm.
But I think we can take we can divide out one of the sign, right?
Yeah, we should.
Yep.
Yeah, I believe so.
So it just becomes
Excuse me. Sorry.
sine x plus 1 plus cosine squared x all over 1 minus cosine x. I think
Mm-hmm. Yeah.
would be the final.
That should be the
I don't
answer.
think we can go much further than that.
Because it can't reduce down.
Yeah. You can't flip it either and make it into tangents or anything like that. It's pretty stuck. I think that was the purpose, was just to
Yeah.
lock it so you couldn't do anything to it.
Teach.
Okay.
Well, I'm curious if we're allowed to flip it over in the beginning, because then we could just turn it into...
Yeah.
Yeah.
Then it would just be like 2 minus 2 cosine x over sine x. I don't know if we're allowed to inverse it without messing it up.
Yeah, I still learned that myself. Because I still remember we can change Pythagorean
Because
identity.
the first one's just cotangent. So it's cotangent plus tangent.
Be equal.
I'm not sure if you're allowed to inverse it back or not.
I don't think you can.
Yeah. I don't think so. I think we just have to find the common. All I know is we have to find the common denominator using what we have at the time.
Yep.
And then from there, somehow.
Yep. So I think what we've got is the correct.
Yeah.
Yeah. I'm going to stick with my gut with that one.
There.
Yeah. Okay, let me go back to the quiz. Okay. Now we have
Oh.
tangent alpha cosecant
Squared
minus.
minus 1.
So I'd say the first step would be to break down secant or cosecant.
Yep.
Yep.
So, what is that? That's going to be 2 over 1 minus cosine 2x.
Yeah,
1.
I would.
Yep.
That's what I would
Because
think.
it's inverse of the sine squared function,
Mhm.
or whatever half identity thingy.
Yeah.
Power
Sorry.
reduction identity.
Yeah.
And then we times that by tangent of A. Tangent of theta. And that's
Cosecant squared. A should give you 1.
What do they want us to do with the tangent? That's what I'm confused.
That's what I want to know.
Yeah, I want to know that myself.
Or maybe they want us to reduce it into the sine over cosine and then times it.
Mhm. Okay. Let's see.
Okay.
Oh, fetch.
Can we use any of the identities here? There's the sum and differences, Pythagorean, or the. I can't get the other one right now. It's like the exact ratio or something like that.
Sorry, my phone just went.
Oh, you're good.
What are you saying? Can we use any of the what?
Can we use any of the identities? So, like, the identity formulas or whatever.
I don't know.
Let me go look.
Tracker
Usually.
Tangent A
If we
is 1.
times both sides by 1 minus cosine 2x, so 1 times that would make it They make it positive.
Should come out.
That's not what I wanted. The
Oh, I'm doing this wrong. Never mind.
I'm pretty sure we can use one of the identities for this one. I don't think it's the sums and differences identity would have been used on the last one. No, and then we brought the Pythagorean in. The Pythagorean. I think we could use the Pythagorean. Yes. Just refresh my memory on it. Okay. So, we'll pull up for me.
I know the questions in the book look so much simpler.
Oh, I know. Okay, basic identity.
Should you break that down?
Oh. The first one might have been a little easier. Yeah, so cosecant is 1 over sine. So we would have, is that what we have? The 1 over sine?
X.
1 over sine x over did you do cosine minus?
Not squared though, right? So what's that do? Because it's squared. So it's just 1 over sine squared.
Yeah, it should be
1 over sine squared
it should
x.
be 1 sine over squared.
Oh, guys, guess what I just found in the book?
What?
The answer?
Something that could help us. Let me pull it
Okay.
up 1 second. I think it can help us. This right here, secant squared of x equals 1 plus cotangent of x.
What the frick?
Where's that?
Where's that? That's on page 424 in section 6.1, basic identities.
Hey, Jeff. What the heck? You want us to use all the chapters? I did not know that.
I mean, we are doing all of them today with this, so.
Yeah.
Usually she seems to focus on what we went over the last time, but yeah. So could we turn that into cotangent somewhere instead?
So you said 624?
424.
424.
So if we change tangent,
Snow on the car.
it should come up with sine x or sine A over cosine A.
Yeah.
If we change the whole thing, yes.
We could probably do something with this right in here. That
Because I changed
cotangent.
Yeah, that's cotangent. Well, cotangent is like 1 over like sine over x.
Yeah, cotangent is the cosine over sine.
Okay, that makes sense. Okay, I'm gonna do that. Equals sine of A plus 1 A minus 1. So where do we go from there?
So sine squared equals cotangent?
Yes. Wait. Tangent should be cotangent. Yeah, it should be cotangent.
Not seeing it.
Tangent of A is 1 over cotangent.
So yeah, we're using a Pythagorean identity here.
Okay.
With it. No, that's not what I wanted. Go back.
How would you even simplify that down?
Would we take tangent times the cotangent squared instead or something?
Tangent of A should be 1 over cotangent.
Let's see. Go to the next page, not the next thing. Okay. I want to try and get this one done before I have to head out.
Cosine squared x.
One side. Yeah, 1 should be 1 over sine squared minus 1. If I was changing the whole thing, yeah, this would.
That means if you were to do something, taking tangent times cotangent would give you cosecant squared.
Okay.
Okay.
Mm.
Have you gotten anywhere closer to an answer, Caitlin?
I don't think so.
So I think I figured out. You get
Oh, go ahead.
the 1 over sine squared x,
Uh-huh.
and then it's minus 1. But you
Uh-huh.
can rewrite the 1 as sine squared x over sine squared x.
Yeah.
And so when you minus that, it's just like 1 minus sine squared x over sine x.
Uh-huh.
So that becomes cosine squared x because of the Pythagorean identity.
Yep.
Okay,
Over
yeah.
sine
Yeah.
x.
Yeah.
And then if you times that by sine x over cosine x because of tangent,
Mm-hmm.
it should just become, what is that? Cosine cubed x and sine cubed x, or sine cubed x over cosine cubed x.
Okay.
And then
Okay.
I think you can reduce that to tangent cubed theta, right? I'm using x, but you can change it back to theta.
Yeah. That's
Yep.
that's what I do too.
I think if it's, I'm not sure though, if it's squared or cubed inside the thing, I don't know if you can switch it back or not.
I don't think you could.
Sure how that works. It's either that or we just have to write it like just like that.
Okay.
From what I can tell.
Yeah. I'm gonna try this again. I'll send you. I gotta skedaddle because there's snow all over the ground. But
Okay.
Okay.
I'm gonna try looking at it from the cotangent point of view
Okay.
a little more and see if I can find something with that, and then
Okay.
we'll decide.
Do you understand the way I went, just in case your way doesn't work?
What was that?
Using going the sine and cosine way.
Yeah.
Okay. Alright.
Hey, I'll just keep you guys going, and when
Okay.
you're done, you're done. Okay, good luck.
Thanks.
Come on, Nate. Give us some of them bright ideas.
I'm trying to give you some bright ideas, but sometimes my bright ideas get you wrong answers. So.
It's supposed to end with cubes, though. Is that what the book wants?
So what was your full answer?
Ooh. Oh. I ended up with sine cubed x over cosine cubed x. But I'm kind of thinking that going the cotangent way might be the way to go.
Yeah, I think so. Because if that would be the case, then you should just have like tangent.
Yeah.
See, that's one of my bright ideas. Because if that was the case, then it should be tangent. Because it says in the Pythagorean identity.
Yeah. So,
Sorry, my bright ideas suck.
no, I think they're good.
Yeah, I'm gonna put that in tangent.
If we go tangent way,
This.
so
I think it's talking brother Miller about TA form.
Let's see.
Sorry, form.
tangent equals 1 over cotangent, right?
Did that? Then.
Yeah, tangent is 1 over cotangent.
Awesome. So they car together.
Okay.
So I'll drop you off and then I'll park at SDC or something, and then go talk for a bit. What time are you done with us?
1:15.
And I'll just go play basketball for a bit.
Times should be cotangent squared.
So I did 2 ways. So I switch every single one to the Pythagorean identity.
Mm-hmm.
So what got? I don't know if that was the case.
Oh,
So we got like 1 over cotangent equals 1 over sine squared a minus 1. And then I kind of did the 2 parentheses to 1 sine over a plus 1 and 1 sine over a minus 1.
Uh-huh.
And then that equals 1 cotangent of a. I don't know where I go from there.
Yeah.
It's like, how would you even basically distribute?
This is freaking weird.
Yeah, I know.
So I think it's just tangent cubed. Either way you go. I think it's tangent cubed theta.
Because of
Because
the
my answer I end up with, sine cubed, cosine cubed. And if you do it the way Caitlin was talking, you end up with 1 over cotangent cubed x, which is just tangent x, or tangent cubed theta. So I think either way, it's just tangent cubed theta.
Yeah, I'm gonna leave that one.
But I'm not sure if you can inverse those like that when they're squared or cubed or all that jazz.
You can't inverse them because it doesn't explain how you can inverse in some of the chapters that we did.
Yeah. I'm not sure if it being squared messes with that or not.
So you think we might need to like get that into just not as squared?
Not sure. Well, if they're cubed, you should be able to break them up into like sine times sine times sine, which would just be like tangent, tangent, tangent. I think.
Yeah. You think you want to leave it like in tangent form?
I think it's supposed to end in tangent form. I'm not sure. I don't understand this stuff enough yet to know what the heck they want.
Yeah, and this is why this one gave me a headache last night.
Yeah. Equals.
Hmm.
No, you can switch them. Because the book shows it as 1 over cosine squared x
Yeah.
or secant squared x.
Oh,
So-
wait. What page are you on?
424.
Okay.
Just above the Pythagorean identity, they do
Yeah.
it right there. So you
Oh.
can just swap. So this cosine squared doesn't change that you can play with identities and stuff. So the answer would just be tangent cubed theta.
Okay.
Alrighty. Does Caitlin watch the video to get these answers, or do we need to send her like a picture of the work?
I think we need to tell her like where our answer is
Okay.
and how.
Okay.
I think that's probably what she's wanting. Or she could probably watch the video and it's like, oh, where'd you get that answer from?
You want to text her and say B is tangent cubed theta?
Yeah.
We tried it both ways and got the same answer. So Caitlin was on the right track.
She was
got
on the
the
right
same answer.
track.
So it's got her answer. Her way was a lot easier than the way I went, but it still gets the same answer. So I think it's like it doesn't matter, and it should be the same.
So it is tangent cubed
Theta.
theta. Okay. Okay, I texted her that.
Work on number 2.
Yep, let's go on them too.
How the
Ugh. What the fetch? How in the world?
it equals 0.
Yeah. That's weird. Oh, that's why Caitlin skipped the quiz, because she doesn't want to do it. I was kidding. Oh, fetch. I don't think. Okay, so 0 equals cotangent of x sine of x minus cosine squared x. That's secant of x. Oh. So we have cotangent of x.
N squared x plus. This is interesting.
I wonder if it was in the assignment. Okay.
Verify the following identity.
So for okay, so it's code x, sine of x minus cosine squared x. What the frick?
This is super confusing.
It kind of is. Because I don't see it in the book.
Maybe it'd be easier to manipulate the zero to where it looked like the others than to manipulate them and make them look like a zero.
I still wonder if our first step is to change all of them to Pythagorean identity.
Oh no. Freaking weird is what it is. What the heck?
What? I wonder where you start first. I'm so confused. Oh.
Okay.
This is a tricky one. So where do we need to start first? That's my question.
I'm just gonna start writing it out. Times 9.
So basically everything needs to be equal to 0.
Yep.
Crap. Taylor, I want to go home.
What is secant? That's cosine? 1 over cosine?
Yeah.
Okay.
Squared.
Sine.
Wait, oh, no.
Sine.
Oh, that's a minus.
Minus. Cosine.
Cosine squared. You're going to have with cosine minus. Cotangent is
Actually, cosine.
sine. It should be sine, maybe. It should be cosine over sine x. Oh! Wait. I did this yesterday.
Did you?
I think so. Yep. That does equal 0. Okay, that makes sense. Ugh. I think I did
How
this
do you do
last
it?
night. Okay, so in order to get 0, you gotta change the cotangent and the sectangent into their own Pythagorean identities.
Cotangent?
Cotangent is cosine of x and then sine of x.
Okay.
And then just leave the sine x and then go on to the sec, and that should be like 1 over cosine. Because cosine squared, it's going to be leaving like that. You just have to multiply them both. Because since cosine squared and then 1 over cosine, it's going to give you
Doesn't
just
that become
one
cosine cubed?
No, because one.
Because it's cosine squared x over 1 times 1 over cosine, right?
Yeah. Yeah.
So that just becomes cosine cubed because 1 times 1 is 1, and cosine squared x times cosine is cosine cubed, right?
Kind of. Kind of. Try. Cause I remember doing this last night. Because I'm gonna have. So I'm gonna have like both cosines at the end. I have to subtract from one another, and that's why I got 0.
Wait, how do they do that?
So all of it, at the end, you should have like a cosine of x minus cosine of x, because cotangent is cosine over sine, and then since we
Okay.
have a sine of x, that should get rid of it, and that will leave you with cosine of x.
Okay.
So the first thing, you should always have the minus and the minus. Or the key is the minus.
So you wrote it out as cosine over sine times sine x minus cosine squared times 1 over cosine.
Yeah.
And then what did you do from there?
So I multiply. So because with the cotangent and the sine, they are together, they're multiplying.
Yeah.
So what's going to happen is that the sine and the sine are going to cancel each other out. And that's going to give you cosine. Sorry, you can't see my face.
Okay.
You're still confused?
Oh, I see. You just put it over top.
Yeah. Because we want to have
So
0 at
cancel
the
out.
end.
So you just get cosine over 1, or just cosine x minus.
Yeah, cosine x. Because you want to have 0 at the end. That's the key.
Yeah. So what do you do to the other side?
This one, it's kind of a little bit tricky. So, how to explain it to your words? Sorry, that's not kind of a harsh compliment,
I'm doing
but
it wrong. I was trying to divide them. No wonder I was having so much trouble.
okay. So, with this one,
So
you are gonna have cosine squared, and then 1 over cosine.
Yeah.
Because since we're multiplying both left and right, you should have cosine to both sides.
Yeah.
Because since we're subtracting, that's why they got 0. Because both cosines are going to cancel each other out, and that is why you're going to have 0.
Okay.
Not 1. Because 1 never works.
Okay, so cosines cancel and the 1s cancel. So it just leaves you with cosine
Yeah.
x. So cosine minus cosine equals 0. Okay.
I think. Because I think I did this one last night, and it looked exactly like the homework quiz that we're doing right now.
Yeah. Makes sense.
I think I'm going to say, like, both cosines will cancel each other out, and that's why they got 0. See,
Cannot believe I spent 10 minutes trying to divide them rather than times them like I was supposed to have been done.
I mean, and see, I'm going to sit, because you told me it's like, you need to be more involved. It's like, yes, I'm involved.
Who told you that?
You,
When did I say that?
20 minutes ago.
Oh, I said give me some ideas.
Yeah, those were some ideas.
Okay. Thank goodness. Well, they were good ones. I don't regret it.
Because I think this was from homework assignment from last night. Because I remember doing this. I think that's how they got 0.
Uh-huh.
Because the problem is, if you have like 2 squared cosine minus cosine, you're gonna have 1 cosine of 1 cosine. And it's like that's not gonna give you 0. That's gonna give you like a cosine.
Yep.
So that's why I think you should have like both cosines on left and right equals 0.
Yep. Okay. I got her now.
Revelation, Taylor.
Straight up revelation.
That's right.
I told you to ask the Lord, and you did, and you got an answer.
I know. When we're at our lowest point, the Lord gives us revelation.
Alrighty, how do you do B then?
That's why I go to the temple very often.
What the heck? One plus
Okay.
sign.
1 sine squared x over
That is extremely.
difficult.
Yep.
Uh-oh. That looks like bananas. Oh, drop the mic.
Which side to do is the question.
Um,
Well, that should rewrite as cosine squared x over 1 minus.
because you're gonna have, because cotangent is 1 over sine. But what is this ugliness? French.
This is freaking retarded.
Crap. How would the teacher do it?
I have no idea.
Does she? Do you think that she? No, that's not right. Do you think we should need to find like the least common denominator?
I don't know if we can, eh?
Because of that equal sign.
Yeah.
The only way to get rid of that is to do the multiplication.
Yeah.
If I was Caitlin, what would I do? I'm not being idle, Taylor. I'm thinking like what Caitlin thinks. Oh, perfume boys. Whatchamacallit? Just kidding.
She's married. She doesn't think about boys. She only thinks about the boy.
The boys, yeah, sorry. Actually, she's probably talking about Jesus and her husband.
Okay.
Sorry.
But I wouldn't call Jesus that.
Yeah, sorry.
Unless you
I'm
did
trying.
it, I like him. But, you know. You do you.
You do you and I do me.
Yeah. I'm far enough away that I won't get hit by the aftershock, so I don't really care.
If she actually saw that, she'd probably be mad. She would be mad.
I hope she tells you to go to your room.
She better not.
Alright.
Okay.
What the frick? I don't
'Cause
see
that's
any
what
way
I
to
was
manipulate this dumb.
Because the only way you could is you do the what was it? The inverse of it? But that was gonna give you 0. Because I don't know where to start first.
I don't understand. How the heck?
This looks like crap.
This looks like somebody took a dump.
because I know that this one maybe be on the quiz for tomorrow. Good golly. This is like 10,000 times of heavy load.
Multiplying. All right. Well, let's try some weird stuff to this, shall we?
Yeah. I think we should.
So, we'll try breaking it up to see if that helps at all.
Yeah, I'm gonna break up the first one or the second one. So I'm gonna have 1 sine negative x over 1 over sine of x. This one have 1 minus. Achoo! Gaylor, are we in heaven?
Hey, if you times, let's see, divide something by 1 over something, it just becomes by that, right?
For which one?
So, CSC is just 1 over sine, right?
Yeah, 1 over sine.
So if you have sine squared x divided by 1 over sine negative x, it just becomes sine squared x divided by sine negative x, right?
Yeah. Yes.
Okay. So we have 1 minus sine squared x over sine negative x. So
But then for the other side,
yeah,
that one's a tricky one. Because cotangent is 1 over sine.
Yeah.
How would you even reword that?
do not know. How do you get rid of a squared? That doesn't make any sense.
How would Caitlin would do this? Actually, I don't want to. How would Caitlin do this?
Let's see. If we times this by a negative 1,
Okay.
it becomes. That doesn't help.
So it would be 1
It doesn't help us though.
plus. Oh, this doesn't help at all.
Such and
So, second part I did, I re-changed everything, and it looks ugly. And I don't think the teacher would want us to do that.
Yep.
Crap. Caitlin, if you were here, you would be amazing.
1.
Okay.
I'm gonna try a shot in the dark right now.
So you're just gonna wing it?
I'm just gonna try to wing it for a second.
Okay.
-1 divided by. Find out that.
I'm gonna look it up. Because that has to be. Because this is a quiz. Gosh. All right.
Pitch. Hmm.
I wish I was Jesus. You'll
Why?
probably know. Because he knows everything. You know what the answer is.
But you missed the fundamental scripture that he had to learn it.
Yeah, he had to learn it for himself. You think how long it took him? Years.
He had to learn
But this
algebra too, man.
This is different.
This is different. Back then, if you didn't get it right, you probably got whipped, though.
I know. Come on. How? Because I'm trying to really think on this one.
Let's see.
While we're trying to become like Jesus,
I'm trying to be
be like Jesus. Actually, we're trying to become like Heavenly Father. Dang it. I can't become like Caitlyn. Because I can't have. I'm not a girl. Oh
You're an odd one.
no. She's. I
You're
think
an
she's.
odd one.
I'm so,
I hope
gosh.
she watches this video and she.
If the teacher saw this, she would be probably very surprised.
Did you go worrying about Caitlyn and just worry about the math for a minute?
Yeah, you're right. I'm trying to figure because I'm stuck on
In class, being a good person.
because I'm stuck because I can't find it in the book.
Somehow they're putting it on the other side, and I haven't figured out how the heck they're doing it yet.
Do you think the teacher? Because I know it's in the assignment, but I can't check that out because this is a quiz. I'm gonna cry.
What for?
Because this looks like heck. Oh god, I can't figure this one out. Where do you go from here? That's my question. Hmm. This one's a hard one. Holy cow. Fetch. I wonder if our first. I'm missing a step because I got an error. I wondered if I need to find the least common denominator first.
15 days.
No, that wouldn't make sense. That would not make sense. Come on! This is not like the homework assignment. If I was either Jesus or teacher or Caitlin, who should I be?
Don't see how the heck they manipulated this.
Because the problem is that because of the cotangent, are rewording this? That's the thing. Crap. I'm becoming an old fart. One minus sine squared. Have I done these? Wait, hold on. Sheet and a quiz. Fetch. Okay, so. Well, this doesn't help at all. Oh, this is not good. Because it doesn't explain. Doesn't explain how. Doesn't explain how to work with the equal sign. Flipping tables! I'm super crazy right now. Okay, let's see. Are you like getting close to a solution?
I don't know. Because I don't know how I can manipulate these.
Because of that stupid equal sign.
You know,
Dang it. I wish it was like a multiplication thing.
okay.
Caitlin will be in our spirits. How in the world?
Cosine over sine is cotangent, right?
Sine over sine is cotangent? Wait, sine over sine is cotangent? Or
Isn't
you,
it?
you mean sine and cosine is tangent?
Cosine over sine is cotangent, right?
Yeah. This doesn't help at all. I just wanna fall. Just kidding. Hmm. Dang it. If I was do you think we need to like so I'm looking on 6-1, I think we need to try to find the least common denominator.
Okay.
Because right now I'm looking on the equal sign on 6.1. The only thing that they did is like they did the least common denominator first.
Okay.
So let me try that.
Try that. Tell me what you get.
Yeah, I'm gonna see where that goes. Because I want to get the right answer. Okay, so I have because of the YOLO! Hey, dork. Oh, this is freaking YOLOs! Okay, let me see. That'll be on one side. B. Cosecant. No, that doesn't work. Dang it. You're right, Kaylor. That didn't work.
I don't understand how the frick you're supposed to manipulate that.
Because I tried the least common denominator, and I got, like, all the answers, like, jumbled up together, but that's not right.
Work on this side of the equation, usually the more complicated one. So it looks like the other side, there are some exceptions to this rule.
We can't get help from our teacher because this is a quiz.
Well, it takes her forever to answer anyway.
Yeah, no. This is like deep studying. That's not right. I'm trying to find... Like, how would you even solve with an equal sign? That's my question. Equals what? How in the world? Cosine of A. But that doesn't help at all. I'm looking on 6.2. That doesn't explain how they changed the sign. Let's see. What? What is this? Oh, maybe I found it. Oh, wait. Kaylor, go check 6.2 example 7.
6.2 example 7.
Yeah. This almost looks like it.
Oh, it's the same fetching one.
Oh, dang it.
You're kidding
Oh,
me.
wait. Prove that the following equation... Oh, wait. Yeah, oops.
No, look.
I mean, this kind of looked almost exactly like it.
You have to be freaking kidding me.
What?
Oh, my goodness.
Wait, did that help?
That's all. Oh, yeah, that's a fetching answer, man.
No way. What?
So I did it right at the beginning. I just wasn't manipulating the other side. I kept trying to just manipulate one side.
Oh, so wait, did it helped?
Yes.
What?
Yeah, and we.
Say 1. That's 9. Squared x.
So I was right. You're supposed to do that. Oh,
I just manipulate the other side too.
okay.
I was not seeing. So they were finding least common denominators, but they waited till like they had done a bunch of stuff to it.
And that's why they probably got cosine squared
Yep.
t over 1 plus cotangent of t.
Yep.
Interesting. Well, that actually helped.
Equals 1 minus sine. Pain in the butt.
I know. I had to look for it in the book and I couldn't find it.
X.
Okay, so be 1 minus. So, okay.
Okay. Equals 1 minus sine squared of t. See,
Should give you.
t sine.
Oh.
Okay. So that becomes cosine squared x over 1 plus e s c t. Oh, that should do that. Sine times 1. Oh, fetch. That's how they do that. Sure, they did do at least common denominator, but they manipulated it quite a bit before they did.
Yeah, before they got to the end.
Yeah. The pot lickers.
Or they're
That's what they are. Pot lickers.
hashtag pop suckers.
Okay. So it does equal that, but you have to manipulate the heck out of it first.
Yeah. Without my brains, we would have been fried.
Yeah. So can you send Caitlin a picture of how we did A, and then just say for B, look at 6.2 example 7, and it'll
Okay.
show her exactly how to, so that she can write it down on the quiz. You wrote down how you did A, didn't you? Because you're the one that showed me how to do it. So.
Yeah. I'll send her a picture on that. Hold on. I gotta get this to work. What do you want me to say to Caitlin about number B?
B.
Yeah.
Just tell her to go look in 6.2 example 7. It'll show her how to do it. Working on both sides. Because it legitly has the exact same, has a different, it uses T instead of X, but it's the same problem.
So what we're gonna put for an answer?
For a B,
Yeah.
it'll be a long drawn out process of writing it out.
Yeah.
So like, the one side, you convert it to where it's cosine squared x over 1 plus cosecant x,
Mm-hmm.
that left side, and then you take the right side, and then you, because sine of negative x is the same as negative sine of x, so it becomes 1 minus sine x over cosecant x. You got that?
Yeah.
And then you do a least common denominator. So you times you times the top and the bottom by 1 plus sine of x, which gets you 1 minus sine squared x, which will give you cosine squared x on top. And then when you take cosecant of x times 1 plus sine of x, it'll give you 1 of the cosecant out with the sine and just become 1, because 1 over sine times sine x, so then you get 1 plus chance of x equal to side. Oh, how that works?
Yeah, I see how you did it. Can you text Caitlin on that?
So that's just what the book shows. That's why I said
Okay.
it's super easier to use the book to explain it than to try to write out all that.
Because
Sure.
even just writing about it, gosh.
Because if you look at example number 7,
Yeah.
that's legitimately what I just told you.
Yep.
Like, it lays it out how that works.
That's so different.
Uh-huh. Yeah, so complicated.
I know.
Do you know what I can't figure out?
What?
Well, in the Google Hangouts, like, what is it, preparation, extension problems?
Yeah.
They made a triangle, but I don't know where the heck they got some of their like figures from.
I still don't know either, to be honest.
Somewhere they got 3, 5, and -4 from somewhere.
You think they changed it?
I don't know. Oh, they just used Pythagoras theorem.
For which one?
No, they didn't. How did they find out that it was negative? Oh, I have. Okay. Yeah, they used Pythagoras theorem. The buzzards.
Oh.
So, because they sine of theta equals 3/5. So it's up 3 with a horizontal of 5. But how does that work with? I'm still confused.
I'm so Yeah, I don't know either.
Equals 1 over 10 because.
Okay.
I don't know.
I don't know
This is
either.
super-
Well, I don't want to leave you hanging, but I got to go because I got to start writing my opening paragraph for my English class. So, and she wants us to give us like 2 hours on it.
Yeah. Alrighty. Well, I think we got the quiz done anyway, so.
Okay, that's actually the good thing that we need to do.
Yeah.
We can start working on the discussion thing. Probably, yeah.
Alright. Good luck, Nate.
Thanks,
See
Caleb.
you probably maybe Sunday.
Yep.
Bye.
Yep.